My name is Norway.
My name is Christopher.
And my name is Jonathan, and we are Team StradoSphere.
We use a string.
We use foot warmers and a lunchbox.
A homemade video reflector.
And a GPS.
A GoPro camera. And an 800 gram helium balloon.
A parachute. And we attached a tiny violin to everything.
And then we sent everything to space. Our primary mission was to discover the polar jet stream using the violin. Our secondary mission was to create a video for the Oslo Philharmonic Orchestra. 5,000 Norwegian students saw the violin video.
We believe we discovered the location of the polar jet stream at about 27 kilometers in the stratosphere. Our findings show a dramatic change at about 58 degrees latitude, at about 27 kilometers. Because of the location of the polar jet stream is accepted at about 60 degrees latitude, our findings measure a shifting of this current. We have sent two other balloons to 33 kilometers and 23 kilometers. We used 13 years from these missions to prepare for Odysseus.
In the Telenot mission, we measured atmospheric pressures by seeing how big the small balloon expanded in the stratosphere. We used gas laws to determine air pressure at 23 kilometers.
We were the first in Norway to launch a balloon to 33 kilometers in June 2011.
We attached a model of a Stradivarius violin to a GoPro camera.
The camera was placed in the water-tight boxing.
We used spot GPS tracking. A spot is good to use since it does not really rely on a mobile phone network. We calculated that we needed to free lift 2.5 kilos to achieve an ascent rate of 5 meters per second. We used a balloon burst calculator to figure out exactly how much helium we needed. Because we're a small school, we had to improvise to save money. So we used free weights, and the balloon had to lift all weights with our payload, our parachute, and our radar reflector. Here are pictures from our video from our first high altitude mission, White Eagle 1. Here are pictures from our Telenot mission. We are very, very happy when we found the Telenot. We had several balloons of different sizes because we knew we had to send up a balloon quickly to adjust to strong western winds. A smaller balloon of 600 grams could rise rapidly but not ascend as high as an 800 gram balloon, and our chance of finding the payload again will increase. Permission to launch was granted from the Norwegian Air Authority on December 6, 2012. Team StradoSphere launched the balloon on a cold winter day in a small town, Algor, at 9:18 in the morning. Because of our 1,000 gram payload, we decided to go with an 800 gram balloon. Our ascent rate would then be 5 meters per second. From knowledge of our ascent rate, we could determine the height of the balloon by comparing the videos of the ascent to the elapsed time. The duration of the video we captured was 4,000 seconds or 1 hour and 6 minutes.
The Find Me Spot GPS unit worked flawlessly even though we lost signals during the balloon ascent. When the signals returned after 1 hour, we were very relieved. We used open source audio software to analyze the waveforms using the Fourier analysis. We slowed down the video to carefully analyze the audio.
We discovered a relatively quiet zone in the upper atmosphere between two distinct areas of increased activity. While there were many changes in the wave shape and frequency, we focused more on the more obvious changes. We discovered 3 regions of increased audio activity. After 33 minutes of ascent to 12 kilometers altitude, after 50 minutes ascent to 18 kilometers, and finally after 67 minutes ascent to 25 kilometers altitude. The violin string snapped at about 30 kilometers at a frequency of 5,700 Hz. When we slowed down the audio, we actually heard the individual strings playing a tone. It appears that wavelengths increase at higher altitudes.
The higher altitudes, the frequency shifted higher.
The dramatic changes occurred at 12, 18, and 25 kilometers.
We believe that we found at 25 kilometers the high polar jet stream over Norway. Also another lower jet stream was possible at 10 kilometers.
At 25 kilometers, the violin string snapped.
Our next mission, White Eagle 2, will be sent up CanSat Arduino hardware or CanSat kit, so we can accurately determine altitude.
We would like to thank Per Olav for his incredible help, and the Oslo Philharmonium for their wonderful support, and also thank Andreas Wahl for his terrific support.